Calculating rates notes, part 2. Notice there's no practice for the reaction rates introduction lecture. The only practice this last week, is on this lecture, calculating rates notes. Calculating rates. Calculating rates is based on two things: the change in concentration of reactants and the amount of time it takes. There are two types of rates: instantaneous, which looks at a simple instant of a reaction and finds the rate and average, which finds the change in concentration over a time period. In class, we will worry about only finding the average rates, because if we found the instantaneous rates, this would require calculus. Calculating rates, part 2. To calculate rates, you need concentration and time. Time will usually be seconds, but concentration can be molarity, moles, or grams. Most commonly, it will be molarity. To calculate a rate, you subtract the starting concentration from the ending concentration. Then you divide by the ending time minus the starting time. Much like finding the slope. It looks like this. Notice there are absolute signs outside of the operation, so no matter what you get, the answer must be positive. Let's practice. Take a moment to look at the table. Notice there are two reactants, HNO3 and CaOH2. Also, notice that the units are in molarity. The concentrations are going down as time increases. The time it took for this reaction to take place was 15 seconds. All right, now let's look at the practice problem. What is the average rate of the reaction with respect to HNO3 from 0 to 15 seconds? Very well. Notice I'm placing an absolute value. Then in parentheses, I'm going to subtract the ending concentration of HNO3, which is 0.10, by the starting concentration of HNO3, which was 1. I'm closing the parentheses and I'm dividing by the ending time, which was 15 seconds, minus the starting time, which was 0 seconds. Closing the absolute sign, placing that in my calculator, I get 0.06 molarity over seconds. Next question. What is the average rate of the reaction with respect to CaOH2 from 0 to 15 seconds? Now we're looking at the other reactant. Placing an initial absolute sign and an open parentheses, we will start by placing the ending concentration of CaOH2, which is 0.3 or 0.30, and subtracting it by the starting concentration of CaOH2, which was 0.75. Closing the parentheses and dividing that by the ending time, which was 15 seconds, subtracting that by the initial time, which was 0 seconds. We close the parentheses, add an absolute sign, and place that in our calculator to obtain an ultimate 0.03 molarity over seconds. Next practice problem. Take a moment and look at this table. Again, we're working with the same two reactants, HNO3 and CaOH2. Again, our concentrations are given in units of molarity, and both reactants' concentrations decreased as time increased. Here, time also, well, the time for the reaction to take place also took 15 seconds. All right, let's try these practice problems. What is the rate with respect to HNO3 from 5 to 15 seconds? Notice we're not looking at the entire time lapse of the reaction. This time we're only looking at 5 to 15 seconds. Very well. It's the same general equation. Place an absolute sign and an open parentheses. Then we are going to place the ending concentration of HNO3, which is 0.10, and subtract that by the concentration of HNO3 at 5 seconds, which was 0.56. We close the parentheses and divide it by 15 seconds, which is the ending time, and subtract it by 5 seconds, which is the beginning of the time we are concerned about in this practice problem. Close with parentheses on either side of the time and place an ending absolute sign. Once this is in our calculator, we solve it to obtain 0.046 molarity over seconds. Now let's look at the other reactant. What is the rate with respect to CaOH2 from 5 to 15 seconds? Place an initial absolute sign. Whoop. My bad, kiddos. Okay, continuing with this bottom problem. We place an initial absolute sign, open parentheses, and this one is asking us about 5 to 15 seconds, so we are going to place the concentration of CaOH2 at 15 seconds, which was 0.30, minus the concentration of CaOH2 at 5 seconds, which is 0.53. We close the parentheses and divide it by the ending time, which is 15 seconds, and subtract that by the initial time which we're concerned about in this problem, which is 5 seconds. Close the parentheses around the time and place an absolute sign. Put it into our calculator to obtain 0.023 molarity over seconds. Last practice problem. Take a moment and look at the table. You'll notice it is the same. What is the rate with respect to HNO3 from 5 to 10 seconds? Very well. We place an absolute sign and an open parentheses. Then we're going to put the concentration at the end that we're concerned about, which is 10 seconds of HNO3. So that's going to be 0.26. Subtract that by the concentration of HNO3 at 5 seconds, which is 0.56. Close the parentheses, place a division sign and another parentheses, and we're going to put the ending time of the reaction that we're concerned about, which is 10 seconds, and subtract the starting time that we're concerned about, which is 5 seconds. Close the parentheses, add an absolute sign, place it in our calculator to obtain an ultimate 0.06 molarity over seconds. Next problem. What is the rate with respect to CaOH2 from 10 to 15 seconds? In this case, we're looking at the other reactant. We're placing an initial absolute sign and parentheses, and we are going to put the concentration of CaOH2 at 15 seconds, which is 0.30, and subtract it by the concentration of CaOH2 at 10 seconds, which was 0.38. Close the parentheses, place a division sign and another parentheses, and we're going to put the ending time of the reaction that we're concerned about in this problem, which is 15 seconds. Subtract it by the starting time that we're concerned about in this problem, which is 10 seconds. Close the parentheses, add another absolute sign, place it in our calculator, and obtain an ultimate answer of 0.016 molarity over seconds. And that's it. All right, I've attached the practice in your website. Please let me know if you would like tutoring.